Hello and welcome to, I think this would be episode 22 at this point. Building a 2D Flutter game, which will be multiplayer. And as I said, we are not using any libraries, but that only goes for the front end, right? Only for the actual game, for all the graphics, all the sprites and so on. But obviously, now we are building a server to support multiplayer, and we're using a gRPC for that, and that's a pretty big library, and I would not want to implement that from scratch. So we'll give ourselves that and basically use that library. And as you can see, during the break, I kept this server running in the client, and you can see that we have no problem at all. This connection stays open. At least it stayed open for these 5 minutes here. So I think we're pretty good. This is exactly what we wanted. We wanted to be able to have a channel for a client open. And basically what I want to see though is if I can run another. How can I run another client? Can I run another client? Nope. Does it allow me to run another client? How can I say I want to run another client? Okay. Or maybe I can just. I don't want to restart. Well, run client, but I don't want to restart it. Okay, so yes. But it is running, and it doesn't allow me to run another one. So what we'll do, we'll go to the terminal and run from there. So we are now spike over here. So let's just say dart lib client. Okay, so now we have two clients running. And obviously now the numbers will be increasing a little faster because we have two clients updating those numbers. You can see that in between updates from the server, right? We're going to stop this here. We actually sometimes had two client messages come in, right? So definitely we have two clients running. Now we're back to one. And this works as expected. So this is good, very good. I'm pretty happy about this. And as you can see, I'm not doing any check-ins. There are no tags this time. This is just a spike. This will be a throwaway thing. But now we're going to actually start pulling in. So we have this thing. We'll keep this here just in case, but most likely we won't need to look at it much anymore. We just now need to basically define the data types that we want to use for our game. So in order to do that, what we'll do, we'll actually open the our game itself, and we'll look at the models. So, and we'll start with the most simple one. Don't worry about the stats model yet. Let's worry about bullets for now. Well, actually, let's not worry about players. This probably makes more sense. So first of all, a player has a tile position, and the tile position also has an offset. Actually, it doesn't. It's just it's basically, so let's look at tile position first. So we're gonna copy this, copy this like that, and we'll go to our prototype. So let's make this small. We most likely will need this. Let's go to our prototype here, and what we'll say, we say message. They're all called messages, which is weird, because not all of them are messages. Some of them are actually. Can I have a type? Maybe we should come back with that when we just minimized. Let's look at the Proto here. So they're all called messages. Here, for instance, a point. Point is also a message. Can I not have types in a Proto? No, I can't. Okay. Well, so what we'll do, so this one we can make small again since it didn't help us. We'll go back to here and again copy this out. Okay, so we have, this one needs to be, so here's the thing though. What we want to do is how many rows and columns are we gonna have, right? So let's just think about this. 32 in 32, right? And let's just look up like what's the largest int32 number, right? Largest int32 number that we can show. So it's like, what is that even? That's like multiple millions of, right? This is like something 2 billion. No, this is, yeah, whatever. It's huge, right? It's so now if we look at where we need this for columns, we will never ever have that many columns, nor rows. So what we actually can do, we can encode the top position in 1. And why are we doing that? Well, because we're going to send maybe like in the case of bullets or offsets or whatever. And actually the thing is that what we first would need is actually what we can actually do, we can have some sort of message, some sort of coordinate, we'll call it, and it's going to be an int32, and that's it. And it's going to be the coordinate. That's pretty much all it will have. And then we have the type position. Because the thing is, we want this coordinate, so we know we have to pull it apart. We can implement that code in one place. And so everywhere we have a coordinate, we can just then, so we have a coordinate row call, right? So in that basically will encode. So here we can put a comment. I saw how we did comments in this kind of. I'm entirely new to protobufs, by the way. Well, I have used them before, but very, very limited. So I'm still like having to look things up, like how do you comment? Okay, so you comment like just normal comments. So basically, just like as an example, right? What we did here in the route guide, they have a point, and they're using two numbers for that, and that's just like too large. Why would you? I mean, you're not going to have that high numbers in each of them. You can actually stuff them into one, and then we can use bit operations to pull them out again, right? So we're going to say a coordinate encapsulates x and y, or call this row information in one, or let's just say it packs it in there, right? So packs it into one int32, and basically the upper, just say the upper 16. I mean, do we even need 16? So let's just say largest in 16. Yeah, we might. I mean, so we might need 2 of those. Okay, so that's fine. 32,000. I mean, if it's negative and positive, right? So we could have tasks to the left and tasks to the right, negative each, right? Okay, that's fine. Upper 16 bits are x, or the column, and the lower 16 bits are the y, or the row, right? So now in our coordinates, we use a coordinate here, and you always have to give it a number. So that's the type position. And now if you go back to the type position here, though, we still need the relative x and relative y. And so we don't want to send doubles. I don't even know if you can. Is there a double? Oh, there's a double. X, right? But that again is huge. So let's say protobuf. How do they handle double handling? How do they do that? Like, how do they actually make that efficient? Because I think once you have like, these kind of things. Let's just look at efficiency. So let's look at double. Not entirely sure what this means, but it's a 64-bit, right? So it adds 64-bit to the message. So what I'm thinking of is this. Basically, when we have the relative x and relative y in a tile, so let's just say this is our tile, right? And we have 40, a width of 40, right? All we actually need is like from negative 20 to 20, right? So it could actually be so like how many, right? If you have 40 pixels, right, and we divide them by, let's say, 40, and we even divide them by like 3,000, so we get this kind of precision, right? We say 0.01 pixels. We can encode like that. So what we're actually going to do is, instead of encoding this in doubles, we're going to say that we're also going to have coordinate. We might rename the coordinate thing. We might name it packed position or something like that. But basically, that's going to be the rel xy. Right, and so actually let's make it packed. We could call it packed offset. Right, so that means now when we create this tile position for the message, we will actually just go ahead and multiply the double with something like 1,000 or whatever. Then we short it, like we basically floor it. So let's show this in an example. So actually we can probably like we can say rel. So the row call obviously is a row and column in the tile. So row call row and column. So it should actually call it call row, right? Because the column is x and row is y. So it's basically the call row is the column and row packed of the tile, right? Tile column row, and then the rel xy is integer representation of offset from tile center. As far as I remember, we had it centered. So now what I'm going to put here, so for instance, if we, let's just say we have, let's just put an example. So let's just say if we had something like well, x is 1.234 like this, right? So what we then do, we say, okay, we make x, the x part of this, we say 1.233 times 1,000, right? And then we floor that, right? And then in order to get back the real double, we can then just divide by 1,000, and then we get back our double. So then we obviously, like, if this is like a huge number, whatever, we lose precision, but we don't need that much precision. I mean, it's just, I mean, we don't need like subpixels or something. So that way now we can basically pack the entire tile position into like 64 bits, versus before it was, you know, like 32 bits for tile x and tile y, and then 64 bits for each x and y in the Right, so it was like something like yes, something like 174, something like basically 64 times 3. It was huge, right? 192. So now we went from 192 to 64, and tile positions are used in the player, and they are used inside the bullets and everything like that. So that's a good thing to have kind of optimized, right? Okay. Okay, cool. So now let's think about. So let's go back and let's. So we have the tile position figured out. Let's go back to the player, which was actually what we were trying to do. So the velocity, right? So velocity also is an offset. Well, the velocity though has doubles. So so we need to figure out how to pack that offset. So we're gonna have an offset type. So let's see. We already say packed offset here, right? But the thing is that so packed offset is not entirely correct, because the thing is, a packed offset will be different than a packed offset from doubles, right? So there's one version. So we're gonna basically have like this as well, but the way that it gets serialized and deserialized on our end is a little different. So we're gonna say XY and XY. But we're gonna have a packed offset. Let's say we have packed point as well. So then this one is actually more like a point, and this one is an offset. It's kind of weird. So the packed offset basically offset packs double basically XY. So basically I'm gonna say these are double, and this is also double. And then basically a packed point so the upper here is col and the lower are row. Well, I mean, we just call it XY for all the cases. It's fine. So then basically in our tile position, we have a packed point, we have a packed offset. So a packed point is just the difference that it's always ints that is packing, and then these are a doubles that is packing. And then obviously when we are packing ints, right, we can like have larger numbers that we're packing, right? And since depending on the position of the double that we are conserving, we can only pack 1,000th of that, right? So now we don't need the offset anymore, because now we already have it. We now have a packed offset. That's what that is. And the only reason to really create a message for this is to have methods that automatically then convert this. So I want to see if you can somehow provide protobuf conversion. Can you somehow, I wonder if you could provide a type that where you can basically say I want to encode in this Proto language, right? If I can basically define this, define conversion in Proto. I guess you can't, maybe. You can define enums, but I don't see anywhere where we can actually convert things. If anyone knows this, I have the chat open here. If anyone finds anything, let me know. But it doesn't look like this. So we basically need to do this conversion when we get basically in Dart, right? But it's still important to define those separately, because what we're going to do, we can then inherit from the generated classes, and when we call serialize or something, or deserialize, we can then bake in that conversion. So whoever, right, wants a type position back out, or it gets a type position in, doesn't have to know any of that. They just know to call the serialize method. So the angle, that's a double, right? So again, the angle could be, we could represent it as an int. So the angle, right, can be in between pi and 2 pi, between 0 and 2 pi. So even if we take the attempt as 1,000, that would allow us to have about 6,000 different angles, right? Something like that. That's definitely enough. So what we're going to do is, when we now do the player model, we are going to say that so it has a top position. Let's see, top position. All right. Let's see what else we have here. It has a velocity, so that's a packed offset. I wonder if it needs those semicolons or not. Oh, you do. Okay. And then it has an angle, and we'll pack that into an int32. And then we'll have applied thrust. And for now, there's only one Boolean, right? But obviously, once we have more than one Boolean, we can do the same thing that we did with the press keys, where basically instead of having all these values, we're gonna have something like final flags, right, equals, and then we'll have this binary thing. So for instance, this, and then basically this means that this is applied thrust, this is something else, and so on. So we can pack that into one, but we want. Well, actually, yes. Let's actually already do this as flags, player flags. So angle 3, and then we say int32. We also have uints. Okay, that's interesting. Let's think about that in a second. So we're gonna have, actually here we do want the uint32. It doesn't matter because we're gonna interpret it however we want to. So basically we're gonna say flags 4. And so basically with the flags, we're gonna say flags left to right, right to left. So basically the least, or the least to what's it, least to what can come with the word. So let's find this least important versus can someone help me? Higher, most, yes, least to most significant bits. And so basically we're going to have applied thrust. So that means that basically the least significant bit, which means that that's the one on the right, is going to be set if the player applied thrust. And now we can encode up to 32 different ones in there. I don't think there's another. Yeah, there's only 64. So now let's look up the difference between uint and int, if that's important at all. So we have an interesting thing here. All right, so we should probably keep that open. I'm actually going to post that here if you're interested in reading a little bit along. Also going to put that for this episode. Yes, I wanted to find out the difference between int and protobuf. Int 32. How are they different? Okay. So okay, that's weird. Huh. Okay. Did we end up here again? I guess we did. So let's look at scalar value types. So we have an int32, inefficient for encoding negative numbers if your field is likely to have negative values. Use s. Okay. So if we are likely to have negative numbers, we should use sn. So let's think about where we actually want to use them. So S stands for signed, I suppose. So let's think about this. So the packed offset XY definitely could be negative. But the thing is, we're not. That's interesting. So how do we? So we have to keep. Yeah, the packed offset. We have to see how we keep the. I mean, they need to be signed, right? So we're gonna have signed. So I'm gonna put S double here because it can be signed. I mean, double is by. They are signed by default. So these are things that you never have to really think about when you're just doing just in Dart. But now where we're sending these. So we have to make sure that when we set those bits, we basically have to reserve one bit to look if it's signed or not, and we'll figure that out. So the writing the serialization code and the deserialization code will be fun for this. We probably have to write find some way to basically call these like serialize and deserialize directly just with the main function to test this out. But the thing is then that this is definitely not going to be signed by itself because we're just basically going to do bit shifts on it. We want it to be interpreted like without signing, right? So that's fine. So now the tiles, a point, let's just say in our coordinate system is going to be always positive for now. Right, because we have we're using this for tiles, and basically in our coordinate system we have a coordinate system basically where this is it and this is 0, 0, right? And so you should never ever be negative. The world basically only goes this way. It never goes, at least for now, we don't consider it being able to go that way. So we have it unsigned for now. Okay, so then that makes the call row can only be positive. That makes sense, but the relative x and y can be negative. So we definitely have to figure out how to, and we're basically already kind of over-optimizing, but it makes sense when we're defining these models to think about how to efficiently send this data back and forth, because latency is very important, and it's going to, we don't want to overload the server too much, sending more than necessary, and basically this extra work to deserialize and serialize is almost nothing because it's mostly going to be bit shifting and masking and so on. So we got the player model, and then we basically So actually what we're going to try is we're just going to try that. We're going to try to see if we can send a player model back and forth. Right? So what we'll do is we will regenerate. So actually we should have probably, as I said earlier, made a script for doing the Proto C stuff. So this is the one that we use. So I'm going to make a script here. I don't know, regenerate or something. It's fine. We can run it with SH. It doesn't have to run with bash. So I wonder if you can just edit configuration. If there's something like run a script. Is there no such thing as run a script? Oh, shell script. There you go. So we will take the script path. All right, it's going to be. Oh, where in the world are we? I don't know why paste doesn't work in here anymore. It used to work like that. So this is going to be our shell script. Oh, sorry. Obviously, yes, we don't want to change this thing. We want to create a configuration instead. So regenerate. That's pretty much it. Actually, we don't even need the full path. We just have it relative to the working directory, and that should work. So let's just run it. Actually, what I'm going to do is I'm going to, just to see whatever we are changing, just check everything, and we're not going to push this anywhere. This is just basically for us to see before. We're just going to say before we generate. We're not. I just want to see the difference in the generated code as a diff. So let's run new generate now. It's complaining shell script not found. Really? Didn't we put it here? Yes, we did. Why can you not find it? Do I have to give you the full path even though I gave you the working directory? So now it is rerunning. Okay, so press enter. Proto C not found. Okay, cool. So now we need to figure out how to put our Proto C into something where it actually makes sense. So probably, I wonder if this. Let's just look at where it gets installed to. So I wonder if it depends on any of the files that are relative to it. So Proto C, right? I wonder if it needs those include things. Okay, so it's an executable. Okay, so now we basically killed ourselves here. Okay, cool. We got back out somehow. Okay, so we're good. So basically what we probably should do is just copy it. Bin Proto C. We just copy it to user local bin. It should be fine. So now we should have a Proto C. Well, obviously, yeah. Well, when you open another, let's see, another terminal. Okay, cool. So now we have one, and now actually this should work. Okay, cool. So we ran the regenerate. And now let's look at the difference in our generated code. So we got the player model generated. Wow, this is huge. I don't know what that is. I don't know why we suddenly have that and we didn't have it before. Something with VCS, source control, no idea. No, where is this actually? This got generated? Oh, this is idea. Okay, so we probably shouldn't have checked in idea, but that's fine. That's just for us. So now we have player model. I don't know exactly what all this means. This is just helper code for this, but the main idea is that we have a player model now, and we now need to. The thing is though that it's called a player model, but actually then we're going to run into naming things, right? Right, because we're going to have the same names for all these things. So maybe we should just name this. Right, we could call this payload or message. So just so we know that we don't have the same name for the actual object in Dart, and then for the not yet processed object, right, which is basically just the message. So let's look at proto buff naming conventions. So this is style guide. Okay. Song server request, required song name. Snowshot. Okay. Okay. Not really helping. Adding message extra verbosity. Normally you just use without. Even if you use other, because it just import. Okay, so they're saying you shouldn't do that. Okay, fine. So we won't worry about this. So basically, what we probably can do, we can just import. We can just like prefix with gRPC or something like that, or proto dot or something. So basically, what I want to do is I'm going to copy the models in here for now. So let me make a new folder or package. And we call it models, right? And so what I'm going to do first, I'm going to just go ahead. So in our case, even though this is part of the engine, our top position is basically a model. And I'm going to copy this over, but we're not going to use all of this. So let's say Dart tile position. Don't ask me again. Okay, so we're not going to have any of this stuff. We don't need any of this stuff for now. All I want to do is I want to say, how can I serialize this and deserialize this, right? So basically what I'm going to do is I'm going to have a gRPC. So basically so that's the thing, right? So now we're going to have this naming thing going on. If I for now just name this like that, and then that's what I don't like. So basically what I want to do is I want to get this top position, right? So what we're going to do is like as gRPC, or let's say as proto, right? So those are protos, and now I can go back to name this like I wanted it. But the thing is, like, to actually get this in here was painful because my class has the same name. So if I say now I'm going to do a proto type position, deserialize, no, actually serialize, right? We were serializing, And the thing we are serializing on top of already serializing, right? The thing is, like, obviously the protobuf is a way of serializing your data, but we are kind of pre-serializing, so to speak. So, and then we're going to have a deserialize, which basically spits out this preposition, and we say dot from proto dot type position, whatever, data, whatever. Right, that's fine. So we'll do that in a second. But basically, if we are packing int and column, right? So int call. So let's not worry about this part later. Int call is basically the call row is our. We need to pack this, right? So basically, what we're going to do is first of all is going to be the row, and then we shift it 8 by 8 by 16 actually, right? And that's it. And then we add the, hold on, it's call row, so actually it needs to be call and then the row. So let's look in our protos if that is actually something that we set. The packed point, so we have x, y. So x, which is the column, is in the upper bits, right? So let's say x, y. So the column needs to go in the upper bits. So what we're basically doing, right? We're taking the column. So let's say the column is 10, or let's just say 8, right? So if we want to get 8 in binary, so we're going to say 8.2 string like this. So that's 1000, right? But we have 16, right? So this is this would be 8. So this would be our column. And let's say the row is going to be 4, which, if I'm not mistaken, should be this, right? So we got that. So now basically what we want to do, we're shifting the column to the left. So let's just say we have 0, 0, 0, 0, 0, 0. Right? So now basically what we do, we take the column, this one here, right? And we basically shift it all the way here to the left. And then we add to that this. So now basically we end up with this number where this part is the column and this part is the row. And or maybe I'll just keep this up here so people can look at it more. So this is kind of how we can now we encapsulated the thing, and now we need to actually also encapsulate final rel xy. So how do we do that? Well, the thing, that's a packed offset, right? So and we're doing this here now, but the thing is, like, we're going to have a method to deserialize and serialize packed offsets and and points like that, packed points, so we don't have to repeat this everywhere. So actually, let's do this actually here. So what we're going to do, we're going to have a class packed point, and basically it basically has just a serialize and deserialize method on this. That's it. It's a static thing. So if we serialize a packed point, we want to get a proto.packed point back. Okay, so why is this not happy? Pack. Okay, and then we have a method that gets a packed point back. Unpack. And as always, I was lying. This will actually have things on it. Right, so basically now if we initialize this in the constructor like this, so now when we packing, so when we're packing it, it's kind of weird because we're packing a pack point. So no, but actually we are, and we might just name this point, right? I know there are points in Dart, but this is our point. And so when we pack it, we basically, what we do is we take our x, and we do exactly what we did here. xy is this, the x to the shifted up, and then added the y. And why is it complaining? Unused local variable. Oh, it's because we made it static, so yeah, it needs to be and then basically we return a proto packed point. Can we, is there a constructor? Oh, so we have a create. We can't give it something. Okay, so we have to do something like this. So it doesn't take anything in the constructor. X y equals xy. So now we have a packed point. And then when we unpack, we want to get a point back out. And we take a proto dot packed point. And that's our point. Or that's just our data. I should say that's our data because it's actually data. So then basically what we have to do, first of all, we assign our xy equals data dot xy. And now what we have to do, we have to do the opposite. First of all, we have to mask. So we have this value, right? So now how do we get out the lower part? What we have to do, we have to mask it with 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. So now if we end those together, right? If we say end, so all of those are zeros, so this will all be zeros, right? When we end this. And then these will be only one wherever we have one in both places. So now I can see when we mask it like that, we get back just the lower bits, right? So basically what we have to do is so let's just see this thing. What's that number? Let's just say our mask is const mask equals is this in binary. Okay, and so that's our mask 255, kind of what I was thinking, but we're going to represent that with ff. So if we represent it as a hexadecimal number, it's going to be ff. So basically our mask is basically this. And we can actually make that this is actually a const that we can define on here. Okay, and so now what we can do, we can say, okay, the x is basically x equals the xy ended with a mask. And then the y is basically now we're shifting. So now we got this one out. So now we can basically take the same number and we don't need this part anymore. So what we do is we just shift it over by 16. I'm showing this as 8s. Actually, I'm just realizing that. But they're really 16. But so now you can see we got back out the number up here, right? So we're saying then that xy shifted to the right 16. Okay, that should be pretty clear. And then basically I wonder if you can make there was like, I think there's something like factory constructors. So where we just basically have to do this. Oh, okay. Point doesn't have a constructor. It does have, but we just named it wrong. So now we have a way to unpack it. Okay, so now here we don't have to do any of this stuff. We basically just say okay, let's do it step by step. So the thing is, like, I was thinking that maybe we should name this packed top position. Everything that's kind of packed, we should name packed, and then we get also rid of, because that's not just annotating that's a message. That's actually giving information that, okay, you're going to have to unpack this thing, and that kind of makes sense to me. So if you say this is a packed top position, right, and then actually the flags are also in a way packed, but we'll. So yeah, we're probably going to have something like that as well, so that we have packed flags, and so on, right? And we're going to have this is basically packed. All the stuff, everything that we basically need to unpack and pack and unpack, we're going to name packed. So good thing that we still have the regeneration. We can just regenerate now, and we should be happy. So now basically we should get error messages in our tab position here, because now there is no proto.tab position. So we don't need this anymore. We just can say packed. And let's see. Packed point. Okay, so now where do we get this from? I think from here. Where is it actually defined? It's defined in that one that we import. Okay. Usually I want to get the library that where it's actually defined, not some library that re-exports it, if I can. So we got that. This is the mask, but actually the mask, we have the wrong mask, right? Because we looked at 16 to string. Okay, so if you actually do the mask, yeah, so we got that wrong. This is actually just, this is just 8 bits, right? We need more. So it's going to be FFFF 4 times. So we're going to look at this in a second. If we say our mask, basically if our mask is basically 1, 2, 3, oh, well, it's going to be like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's 16. And now we say mask to string 16 is FFFF, right? So the F we need a little more of that. So we have 8. Oh, and hold on, but that's, yeah, we need to basically have more of those, because we have 32 bits in total, right? So and hopefully I didn't make a mistake there. So let's just count this out. So this is 4, 8, yeah, that's 16, and then that's 16, and so now that's correct. And we'll move this because now it's misleading. All right, and so the cool thing is now, so these data types exist, right? Even though we're not running a server. So what we can do, we can actually figure out how to serialize and deserialize stuff. We can make sure that whatever we did here actually makes sense, right? So we got a packed point. We can unpack the point. And we're still not unpacking this at all. So we have the offset. Yeah, so the offset is already a type in Dart, and we're not going to be able to add. Well, we could do extension methods, but that's like just way too complicated. So what I want to do is I'm going to name this a point double, right? We already have so many offsets going on, right? We have the UI offset, then we have our own offset. I do not want to create another offset class. So what do we name it? Let's look at the proto. Maybe looking at this will help. So what are the offsets used for? It's velocity, packed offset, right? We named it packed offset. But actually what it really is a packed fractional offset. A packed fractional point. Because there's fractions in it. It's another word for double, or like float or fraction. Let's see what's a fraction. Numeric quantity, that's not a whole number. Okay. That kind of makes sense. So we name this one packed. It's kind of a mouthful, right? And then basically we can then convert easily offsets from fractional points, but I don't want to name it offset as well here. So, so we have a fractional point, and we're going to have the same kind of thing. We're going to have x, y. The mask is the same, and then we just need to figure out what's the precision. And so if it's like this, that means we multiply by this precision to get back our thing. So that means we can have up to 1,000, right? That's 1 divided by 1,000. And maybe we should make that clear, right? So we have 1,000 precision. Then this will be double. All right. And let me make this constructor for this. Actually put this below the static things here. So it's const. All right, so we have a fractional point, and now we just need to get a packed fractional point out of it. And it's basically the same thing. Okay, well, oh, we need to regenerate now because we changed the naming of things. So we have now a packed, where were we? Packed fractional point. So the x, basically, we need to first get our xy. So final int x is basically the x times, or divided by the, yeah, that's kind of weird. So let's just do the factor is basically let's just say this is 1,000, and then the precision is the factor 1 divided by the factor. So what we'll do, we'll take x times the factor, and then we floor that. Okay, there's no floor. Hold on, what? Why is there no floor? Oh, I remember that. It's actually part of the number, floor. Okay. So now we should, if we type annotate this, this is now an int, right? So now the same is for the y. So we do the y times factor, and then basically what we do int x plus int y, and that should be it. And then that's the packed fractional point. Okay, so now the unpack is also very similar to what we have here. So we have the fractional point unpack. So we get the xy. Now that's the so we get the x and the y, but then basically we have to fractional point. We have to divide by the we have to take times the precision, if that makes sense. But actually I don't like this at all. We're just going to divide by the factor. It's way more sense because it's like reciprocal, right? You can see that in here very easy. Okay, so now we get back our fractional point. And so now the type position, so that's also going to be a pack and an unpack. So when we pack, basically, what we're going to do is we say that the call row thing is a fractional point. No, it's actually just a point, a packed point. Well, hold on. It's actually a point from call, row dot pack, and then the xy is a fractional point from x and y, and we pack that, and now return a pack top position, right? And so then the call row is call row, and the xy is xy. Okay, that makes sense. By the way, if you're confused about the dots here, that's a Dartism where we can keep setting things, and we always keep getting back the instance that we're working on. So we use that to shortcut like that. So then now if I want to get a type position back from a, so if I do factory type position dot unpack from a packed type position, and I know I assume we are running out of time here. I'm going to finish that, and then we'll take 5, and I'll quickly just write some code to make sure this actually works. But basically, or maybe I'll just go over time and make just one episode instead of 2, because I kind of want to keep working on this until we figure this out. So so how do we unpack it? So basically, we need to get first our point back. Is basically a fraction, basically a point dot unpack data dot call row. So if you say call row, right, and then the xy is a fractional point dot unpack data dot xy. You can see how it's very nice that we are getting, like, we know that this is a packed fractional point, right? So we can't make a mistake here. This takes see we made a mistake here. Actually, fractional point needs to be a fractional point. Okay, so this way we get type safety that we basically get from our defining our protobuf. So now all we have to do is return a type position from the column will be call row dot x, and the row will be call row dot y, and this is easy, xy dot x, and then xy dot y. Okay, that's nice. So what I'm going to do is I'm going to create a type position. I'll pack it, and then I'll unpack it. So let's just say we have a type position, and we'll have a column of 2, row of 3, and then we'll have a relative 3, and then let's say 200.00, let's just say 1113, right? And then basically we're going to say the packet first, packed equals tp.pack, all right? And then we unpack it, unpacked equals tp.unpack, or top position. Yeah, the reason why this has to be like this is because we can't add methods to, we could probably inherit from the fractional point, but this is kind of nice because we actually, in our game, we only really care about these things. So we only care about the data structures we actually work with. So what we're going to do, so we're going to copy our toString method here. So a toString message here is basically saying like, where are you? You're basically like this. Okay, so we have really pedantic turn on for our Dart, but that's fine. So basically what we're going to do, we're going to print the TP toString, and then we print the unpacked toString, and then we can compile it, compare it. And then actually if this works, we can call this done. And so actually we kind of did finish on time. Okay, we need something like a semicolon. All right, cool. So what happened here too? So it didn't work, right? In a way that's cool, because we now can figure out how to fix it. But I will still take a break, and we'll fix it. I'll be back around 5:10, so my time 5:10, so in 7 minutes roughly, and we'll try to fix it. We'll have like a half an hour before dinner time, roughly, to fix this, and I think we should be able to do that. So thank you for joining. I'm stopping here again. We'll be back shortly fixing this. I hope you can come back. Thank you.